The normal shooting logic should be that when the basketball is in the idle state, touch the screen and the basketball enters the power-up state. When the basketball is in the power-up state, the progress bar will continue to grow, showing the change in strength. When the basketball is in the power-up state, touch and release, and the basketball will enter the throwing state. After throwing, the basketball enters the flying state. In the flying state, it is necessary to determine whether it is scored. At present, no matter what state, the strength progress bar will change when the screen is touched. Let's solve this problem first. Find the progress node, where the progress bar UI is located. Then find the business logic of touch. At the beginning of the touch, the state of the basketball must be determined. Therefore, we add a property basketball controller in the progress control script. Associate the basketball node in the editor. Because we want to get the state of the basketball in the progress script, we need to provide the corresponding get or set method in basketball controller. To simplify the process, you can also directly modify the modifier of the state property to public and change its initial state back to idle. Add a judgment in the touch start logic in the progress script. If the basketball is in the idle state, call the method to start charging. In the method to start charging, turn on the charging switch. Restore the progress bar to 0, indicating that charging starts from 0. At the same time, change the state of the basketball to the charging state. Let's look at the touch release. Similarly, add a judgment. If the basketball is in the hold state, call the shooting method. In the shooting method, call the throw method in the shooting script. At the same time, change the charging state of the progress bar to false. It should be noted that the progress bar affects the strength of the shot. So here we pass the fill value of the progress bar as a parameter. In the basketball controller script, we slightly modify the shooting method. Make the speed of the shot related to the progress bar. In order to reduce the player's waiting time and make testing more convenient, we change the progress bar fill value at the beginning of the touch to 0.5. Then test. We found that after shooting, it is also necessary to determine whether the goal is scored. In addition, after scoring a goal or after the basketball lands, the basketball should be put on the free throw line so that the player can continue to shoot. How do we determine whether a goal has been scored? We can use collision detection. First, we need to add a collision body at the center of the net. If the basketball collides with this collision body, it means a goal has been scored. Find the net node. Right-click and create a new sphere named NetInner. Add a collision body to this node. Then cancel the mesh renderer on it. When the basketball collides with the collision body in NetInner, the engine will automatically call the onCollisionEnter method. So, we add the onCollisionEnter method to the basketball control script. Add relevant processing logic to this method. If the basketball is in flight, call the flight processing method. In the flight processing method, determine whether the name of the object that collides with the basketball is NetInner. If so, it means a goal has been scored. Run and test. It is found that the basketball has collided with the collision body in the net, and the console output is correct. However, the basketball sometimes bounces out and sometimes gets stuck in the net. This is obviously unreasonable. What to do? This is because there are both rigid body components and colliders on the basketball, so a collision rebound effect will occur. But our basketball needs a rigid body to be controlled by gravity, so the rigid body component cannot be removed. The collider cannot be removed either, otherwise collision detection will not be performed. What should we do? Yes, students with a solid foundation will understand it immediately. We can use triggers. Check the is trigger property in the sphere collider component on the net inner node. In this way, the sphere collider component on the net inner node can be regarded as a trigger. Run again and find that after scoring a goal, the basketball will pass through the net and fall down. But there is no output in the console. This means that the collision detection method just now has not been called. There is a knowledge point here that beginners need to pay attention to. When is trigger is equal to false, the collider triggers a collision according to the physics engine, producing a collision effect, and the on-collision enter, on-collisionst and on-collision exit functions can be called. When is trigger is equal to true, the collider is ignored by the physics engine, there is no collision effect, and the on-trigger, on-trigger stay and on-trigger exit functions can be called. So, we changed the collision detection method just now to the on-trigger method. Then run and test. Found that the goal logic is normal. Under what circumstances should we put the basketball back to the free throw line? The strategy I am going to adopt here is to switch the basketball state to idle when the basketball collides with the ground and its y-direction velocity is close to zero. In addition, there is one thing to forget. When the basketball becomes idle state, the basketball should be put back to the free throw line. So, first declare a variable to save the initial position of the basketball. Then, in the onStart method, record the initial position of the basketball. Finally, in the corresponding method of the idle processing branch, put the basketball back to the initial free throw position. In addition, reset the angular velocity of the basketball to 0. Prevent the basketball from rotating in the air due to inertia after it stops. Run and test. It should be noted that when the basketball falls on the base of the basketball stand, the basketball will not be reset. Similarly, the basketball may also get stuck on the iron sheet connecting the basketball stand and the basket. So, we also need to consider these issues. Later, the basketball may fall on other objects and need to be put back to the free throw line. What to do? Here, we will no longer use the name of the collision body to determine whether the basketball should be put back to the free throw line. Instead, use the level of the collision body to make the judgment. Create a new holder layer to represent the support surface. The ground and the iron sheet connecting the basket and the backboard are all placed under this level. By the way, there is also the beam behind the basketball stand. Although the probability is not high, we must also consider this possibility. So, put the beam behind the basketball stand under the holder layer. Next, modify the code. First, create a new enumeration class. Name it LayerEnum to record the level. Then, modify the previous flight processing logic. Run. Adjust the shooting with appropriate force and angle to test. It is found that after the basketball falls to the base of the basketball stand, the basketball will be put back to the free throw line. However, careful friends will also find a detail. That is, after the basketball is put back to the initial position, the health bar should be restored to the initial filling value. What to do? Let's look at the implementation logic of progress. That is to say, when the progress bar does not change and the basketball is in the idle state, we need to restore the progress bar to the initial filling value. Therefore, we first need to declare a variable in progress to record the initial filling value of the progress bar. Then, in the processing logic of each touch start, change the filling value of the progress bar to the initial filling value. Finally, add an else branch to the onUpdate method of progress. In this branch, determine whether the basketball is idle. If it is idle, change the filling value of the progress bar to the initial filling value. Run and test. It is found that the shooting is normal and the progress bar logic is complete. The goal will also be correctly output in the console. However, in the actual game, the player's score should be displayed on the game interface after the goal. Let us think about how to count the player's score and display it. Finally, there is one more thing, don't forget it. Because we have made changes to the basketball stand, so make a habit of making a basketball stand prefab again for use when needed later. Select the basketball stand we modified and make a copy first. Then delete the original basketball stand prefab in the prefabs folder. Drag the modified basketball stand into the prefabs folder to get a new basketball stand prefab. Unlock the node just now. Drag the new basketball stand prefab to the left hierarchy window to get a basketball stand node. Modify its coordinates and change its z-axis coordinate to 10. Press the F key. Modify its rotation value to rotate 180 degrees around the y-axis. Delete the basketball stand node just backed up.